name is Miss Matthews. I'm an 8th grade physical science teacher here at North Clay Middle School. Today's lesson will be about open and closed circuits. We'll do series circuits as well as parallel circuits. We'll have an interactive lab. We'll do a brief video that rolls out the concepts to the students, and I'm hopeful they will enjoy it as they create these circuits and understand it. Lesson standards. Students will recognize characteristics of gravity, electricity, and magnetism as major kinds of forces acting in nature. Element B. Demonstrate the advantages and disadvantages of series and parallel circuits and how they transfer energy. Learning target. I can describe how a series circuit differs from a parallel circuit.
An electrical circuit is made up of components linked to each other by electric wires. The objective is to transmit the energy contained in the movement of a large number of electric charges to a receiver.
Alright, so everyone draw this diagram. When you have an electrical circuit, how many components must there be? Three. The light is called the receiver. Is this circuit open or closed? Closed. How do we know it's closed? Because the light is on. Alright, so let's remember to keep applying the concepts. Light on, circuit is closed. Alright, and then do me another favor. Draw the diagram quickly and draw little arrows, because what's moving? Electric what? Electric current. Direct explanation. Open and closed circuits. Scholars will understand the distinction between a closed circuit and an open one. They will also learn about series circuits and parallel circuits.
Imagine now that we want to connect a second light bulb. We can put two light bulbs on the same branch, or we can put them on two separate branches. In the first case, we say that the light bulbs have been connected in series.
A series circuit is a circuit where there is only one path from the source through all of the loads and back to the source. Modeling the lesson's concept. I do. So what circuit did we now create?
Series.
A series circuit. Draw it. If you were to look at this picture, you will be able to identify it's a what type of circuit? A series circuit. And guided practice with feedback. We do. So Jamorian, show me the two receivers. Show me the generator. Generator. Point to it. You can use the ruler. Point to it with the ruler. That's the generator. The generator has two different components. What are the two sides of a generator?
Now can I help?
A negative and positive side. Jamorian, show me the switch. Alright, Jamorian, is this circuit open or closed? Closed. How do you know it's closed? The light is on. Jamorian, if I wanted to open the circuit, which component would I use to open it? The switch. Alright, so if one of the light bulbs went out, would this circuit still work? Yes. Who all agrees with Jamorian that if one of the light bulbs went out, the circuit would still work? Who agrees? Why do you agree? It's still connected. Everybody else disagrees. If one of the lights goes out, then what happens to the entire circuit? As Michaela said, we talked about series circuits yesterday. The example that we used was a Christmas light. And we said that if one of the Christmas tree lights go out, what happens to the rest of them? They all go out. What is it called? What is this called? Filament. Write it down. So what happens is the inside of a light bulb is called the filament. It is broken. So if you didn't know why people shake a light bulb, it's to see if they can hear the particles from the filament telling us that the light bulb is dead. You do that typically if, let's say you're trying to figure out if something is faulty. If I put a bulb in, it could be the bulb, it could be the electrical socket, it could be a variety of things. I try to rule out the bulb by shaking it. If I hear the filament particles, then that's my indicator, light is dead. So to go back to Jamorian, if the filament is broken inside of a receiver or a light bulb, does the circuit on a series circuit still work? No. It does not. A parallel circuit has two or more paths for currents to flow through. Alright, so then we have a parallel circuit. So the question becomes, Jamoria said, well, hey, on my Christmas tree, one light goes out, they still work. So what kind of circuit does Jamoria take? Parallel. He may have a parallel circuit. So it's possible he may have a different type of circuit. What type of circuit are we talking about? A parallel circuit. Jennifer, what has been doubled? What do we have two of?
The light.
Also known as the what? A light is also known as a receiver. So Jennifer, show me where the two receivers are in the diagram. Show me the switch. Show me the generator. So if the filament and the first receiver went dead, would the receiver for number 2 still work?
No.
Yes.
Why?
Because
So show me the circuit that would still work. Show me the path that the electricity would flow on for the second one to still work. Show me the path. Just outline it with the ruler. Show me the path of the electrical currents in the circuit that would work if the filament was dead in the receiver for 1, but it still worked in I2.
can I help you? Please.
So think about, start at your generator. Show me the generator. Alright, now start. Act like you're an electrical current going through the circuit. Keep going. Go. Boom, boom, boom. You're going, 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 going. Keep going. Going, 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 going. Okay, you're going, so you're on that circuit. You just lit up the light. Keep going. Keep going. Keep going. Keep going. Keep going. Keep going. Nope. There you go. Keep going. Because why wouldn't you go up to the receiver for 1? Because it's dead. Right? So that means, tell me one good uses of using a parallel circuit. Why would this be good?
Because
Hold on, let's listen to it. Why would this be good?
If one goes out, then the other stuff dies.
Absolutely. Where do you think you could give me an example of this type of wiring? Where will we use a parallel circuit? So a Christmas light can be a series circuit or a parallel light. Give me another example. Where would I want, if one light went dead, where would I want all the other lights to still work and just replace a bulb for that one light? Where would this be good? At home. Where would this technology be good? At home. So we think that in our houses, what kind of circuit do we have? Okay. We have parallel circuits, absolutely. What about somebody else? Independent practice, you do. On to the lab for today. That means you will create a series circuits as well as a parallel circuit. You will look at the notes that you have. You will make sure you understand all of the components, including the voltage and how they all work, and you'll get it started. Once you get it started, and everyone here understands how the wires connect, how you have the generator connected to the receiver, connected to the switch, and then I'll give you another bulb, then everyone would have been able to experience the concept. Does that make sense? Yes. So first, check. With your group, did y'all do all 3 from yesterday? If so, I'll give you the supplies for the lab for today. If not, then say, you know what, Miss Matthews, I need to still do the flashlight one, or Miss Matthews, we're still in the calculator one, can we get the supplies? Make sense? So I'm going to come around, or either send one representative, I'll come around, make sure you have the supplies, and we'll go from there. Students work in groups to create series and parallel circuits. So right now we have Lavanzo. He is going to show us a closed circuit. He's going to create the closed circuit with the switch, a light, and a battery pack. We have 2 AA batteries. All right, so we're going to connect it. Let's see if this works. So what we're doing is we're connecting one of the wires from the light bulb to the switch, and then we have another connection from the battery pack. So which ones? What's the connection? From the battery pack to the switch. Hold it, Sharia.
Where's the black one? You gotta connect to the light.
So the battery to the switch and the battery to the light. In science, it is extremely important that both things have a connection to the source of power, and the battery is a source of power. Alright, it's like Thomas Edison. Will there be light? We will see.
No, that's not how I did it first time.
Oh! Oh! There you go. Awesome. Now switch off. Let's do the switch off. Off, switch on. That's off. That's off. That's on. Off. On. Off. On.